Good morning, everyone, and welcome to our webinar about the DER API with a focus on developing energy. I hope everyone can hear me. My name is Emeline George. I'm an engineer and energy management specialist at gridX. Today, we are going to introduce our API for distributed energy resources. And in this presentation, we're going to go through first the purpose of why using the DER API. Then we will go through the features and functionalities of the API, and then we will conclude with a demo to see the API in action. But I keep saying DER. Maybe it's good to align before we dig into more detail into the definition of a distributed energy resource. A distributed energy resource is an appliance that consumes, stores, or produces energy, such as a battery, a charging station, a heat pump, an inverter, but most importantly, that provides an interface with which we can communicate. And in the Xenon to make an energy application compatible with all sorts of distributed energy resources. If you were to start your energy application from scratch, you would probably have to make a trade-off between the number of devices you can support and the time you spend on the integration. Indeed, there are more and more devices out in the field, more and more manufacturers, and many manufacturers work with custom protocols. So having to integrate so many different devices is actually a distraction from your actual development. With the DER API, you focus on your application and you use Xenon, our platform, via the DER API. The DER API is a simple RESTful API. It offers a unified data structure for all types of appliances. It's totally manufacturer independent. And of course, we ensure the continuous maintenance and improvement of the DER API. So like we said, Xenon then becomes the gateway. Xenon is our platform that becomes your gateway to all the distributed energy resources. You focus on developing your energy application, and you exchange signals, so control signals, and get measurement signals from Xenon or with Xenon via the DER API. Xenon, our platform, then takes care of communicating with all the DERs using their respective protocol. And you can then observe your DERs consuming, producing, or storing energy as you expected them to do so in your energy application. How does the API identify the different DERs? The approach is rather straightforward. It is based on identification number, or UUIDs. So each DER that is connected to our grid box will receive an identification number. Each grid box will be associated to a cluster of DERs, which can also be recognized by an identification number. So that's it, grid box, that is the local gateway to all the DERs, and everything is identified via IDs. This approach easily scales up. So if you now want to control or communicate with DERs in an entire district, for example, let's imagine you have grid boxes in several households, you have public EV charging stations connected to a grid box, you have a central energy plan maybe that is also having a grid box with different DERs connected, such as a central battery, large PV production panels. All this would belong to a big account in which you will have different grid boxes associated to different cluster IDs, and then you can always retrieve all the distributed energy resources that belong to a cluster. So let's now look into more details about the DER API. So the API has, let's say, two main parts. The first one is an inventory. This inventory is extremely important to get the list of devices and their respective attributes. So you can, with this inventory, you can list the clusters and their attributes. You can get into a cluster and get the list of DERs in the cluster. And by attributes, we mean information such as manufacturer, model, a type of appliance, serial number, maybe firmware version, and so on. The second part of the API focuses on the control. And there we have two main endpoints. The first one is the flexibility endpoint. Why do we call it flexibility and not measurement? It's because the flexibility really reflects the entire state of an individual DER. So not only does it give you the latest measurement update, for example, power, state of charge, but it also gives you the status. So is my DER ready for control? Is it available or not? Is it in an error mode? And so on. And then the second endpoint for the controlling part is the constraint. What we call constraint is actually something that limits or restricts the normal behavior of your distributed energy resource. And this is what we use to control the DERs. For example, we use constraint to issue power set points to a DER. So if I want to charge a battery, I would use a power set point constraint with a given power amount. I can also use or restrict min-max power energy levels. It can be useful if you want, for example, to ensure that a minimum energy capacity is always preserved in your battery storage. Of course, this list is non-exhaustive, and we will give more examples later. What do the API requests look like? The first type of request you can do is, for example, to get the list of appliances that you have in a cluster. For that, you would simply put a GET request to the following base URL. So the environment in this case would be api.gridx.de. And then you specify that you're looking at clusters, and you enter the ID of your dedicated cluster. And then you just ask for the list of appliances or DERs. In this example, we retrieve 2 appliances. The first one is a battery. The second one is an EV charging station. But there might be some other information that are kind of interesting to look into more details. So of course you get a type of appliance. So in this case, here is a non-exhaustive list of example types you could get. So EV charging station, heat pump, fuel cell, meter, and so on. And then the second element is part of the attributes. It's the purpose. In this first example, the purpose is the battery. Why do we have this purpose section? Sometimes, actually, the type of DER is not enough to give you a clear understanding of what DER you're actually dealing with. In the example above, you have an inverter. Well, this inverter could be a PV inverter, it could be a battery inverter, or it could be a hybrid, so PV and battery inverter. So this purpose kind of help you see more clearly through the kind of appliance you're dealing with. In the case of a meter, for example, it could also be interesting to know if it's the grid connection point meter or another auxiliary meter. Another type of request can be to retrieve the appliance flexibility. For example, if you place a GET request to the same base URL with the cluster ID, the appliance ID, but this time requesting the flexibility, you will get this kind of response. For example, here we have a time at which the flexibility was updated. We have the power level that is currently consumed in this case, or charged, for example, by a battery. And here it's totally symmetrical per phase. And then we have the energy level of the battery, in this case, 5,000 watt-hour. The next API request could be pertaining to the constraint endpoint. And so for the constraint endpoint, we can get constraint, we can post constraint, and we can delete constraints. So a GET request to, again, the cluster with your specific cluster ID, the appliances and the specific appliance you want to retrieve constraint from, and then constraints, of course, saying you want to get constraint. This is what you would get as an example response. You would know when the constraint was created. You would get an ID of the constraint. Be careful, this ID is not the appliance ID. It's really the identification of the constraint so that you can later on delete it if needed and retrieve it. And then you would get the time at which the constraint expires, the field that you aim to control with this constraint. In this case, you would like to set a power level, and the priority. But what is the priority and what is it used for? The priority actually enables us to make good decision in case you have multiple constraints or conflicting constraints applying to a same appliance and the same field. Let's take this example here. We have two constraints that are created at the same time and have the same validity time. They both want to apply a power level to the power field. The first one wants to charge with 3 kilowatt. The second one wants to discharge with 2 kilowatt. And both have the same priority. So there is really no good way here to decide which one is the right constraint to apply. And in this case, we would just simply retain the last one, which may not be what you wanted. So let's take an example where we actually use those priorities. Let's imagine you have an energy application in a household where you're trying to maximize the self-consumption of the PV production surplus. You have an EV that is set to charge with the available PV surplus.
Hello, my name is Philip. I'm going to talk about the API. Currently, Emeline has some connection issues, so I take over the presentation right now, and I hope she is back soon. I hope you can all see the current presentation. Yeah, as Emeline already told you, we have like different endpoints, and the constraints endpoint is used to restrict the different DERs. And in the constraints endpoint, we have different fields called power and priority. And as you can see in the example below, the priority, or we can have like multiple constraints. So it's like the same priority. So if you see like the created add date is the same, the power value is different. In that case, it's not possible to really charge or discharge the battery at that point because there's like a conflict. So we are returning an error if there's some kind of conflict. What we can do in that case is that we have like different priorities. So you create a constraint and have like an invalid add value and like different priorities. So we are starting with the highest priority. In that case, we are going to charge with 7,000 watt. And if the invalid date is not, or if we pass invalid add date, we are switching to the next constraint with the highest priority. In that case, it would be, for example, the 3,000 watt in that case. Okay, and what we are trying to achieve with the DI API is to build anything based on it. And one use case would be like a smart district. So the idea is, or the goal is to connect all of the DRs. And within this district, we would try to reduce emissions. We try to increase the outer key ratio and especially leverage synergies between heat, electricity, and mobility. And what we are really need for the DR, from the DR API at that point is that we need to know which devices are there, so which DRs we can monitor and we can control. Therefore, we need the inventory. And on the other hand, of course, we need to control the different DERs. And the benefits is that we do not really need to know what kind of DERs maybe we have, because we only need to think about the flexibility in that point. I already heard, or I heard that Emeline is back, so I think she will take over the presentation.
Thank you, Philip, for taking over in the meantime. So I hope you can now see two screens. So let me adjust this a little bit. So I don't know where we got lost exactly, but I would restart there. So here we actually have a grid box that has been set up for the purpose of this demo. It's a household. You can see here the household consumption, you can see the current PV production, and you can see what we are feeding into the grid. Seems like currently the household consumption is rather high, but we can still do a demo use case. So the household also have a battery, and the household has an EV that is currently not charging. And so what we will see in the steps of this demo is what follows. So first, we will try to retrieve the information about the different DERs that are on this grid box. So the first element you need to know is the cluster ID. The cluster ID is, like I mentioned, related directly to your grid box. And in this case, it's this number here. I would just then perform a GET request like we just saw it earlier to try and retrieve the list of appliances that belongs to this cluster. So I write a GET request to my base URL, which is https api.gridx.de. I have my cluster ID, and I request the list of appliances. And if I do so, let's hope that we now have no internet connection issue. Nope, there it goes. So our API responds with a list here. I hope you can see it well enough. It's a list that shows us that we have a meter, we have an inverter for the battery, we have EV charging station, and then we have an inverter for the PV. That rather looks quite similar to what we have here in our demo box. The second step would be to try and get the operational constraints of the DER. So what is currently applying to the different DERs? Again, for that, we need the cluster ID, the appliance list that we just got, and I would simply go through the list of appliances and try and get some interesting information to show you. So the first appliance I would look after is an inverter, can be the battery inverter or the PV inverter, and I would try to get the constraint list that are currently applying to those. And then the second one I would use is the meter. For that, I would actually request a flexibility endpoint to try and get the current status of my meter. So to get the constraint list, I put a GET request to my usual base URL to the appliance ID I'm trying to get the constraint from and asking for the list of constraint. And then secondly, for the flexibility list, I would just try to have the same, a GET request, but this time asking for the flexibilities. All right, let's do that. And you can see here the response from the API. So the first flexibility I was requesting was the meter. For the meter, it's actually telling me that it's currently producing 215 watt. Okay, it just changed now, but that was quite in line with what we could see on the box, that it's relatively evenly distributed between the phases. Then I get information, so the list of constraints of my inverter. The first inverter is actually a battery inverter, and you can get some pretty interesting information from the constraint. The first constraint we see here is a max energy. This is actually a constraint that is set by the battery itself to inform us of its maximum capacity. The second constraint is a min-max power. So the battery can operate between 3 kilowatt and minus 3 kilowatt. And then the last list of constraints I retrieve is for the inverter. This time it's the PV inverter, and it's telling me basically the installed peak power production of the PV. So in this case, it could be up to 7 kilowatt. The convention is such that if we are consuming, it's positive, and if we're producing, it's negative, hence the different signs you can observe here. Then the third step of the demo I would like to show you is how to post and delete constraints to a DER. And we will start with the battery. So again, I'm going to go through my list of appliances, that I have retrieved earlier. And I would try to post a constraint to this DER battery. So for my constraint, I need to create a body for the constraint. And this body must contain a time at which the constraint is created, a time at which the constraint is invalid, an ID, not for the battery, but for the constraint itself, and then the power at which I would like to charge and the priority level. In this case, I would like to charge, let's say, the battery with whatever we are feeding in the grid right now. So I would say 2 258 watts. And I would set a priority of 1 to this constraint. And then as a fallback, I will define the default behavior of my battery. My battery should always return to a power of 0 when it's not anymore applying my current new constraint. So I will post the constraints by doing a post request to our base URL cluster ID, appliances, battery ID, and then just saying I'm applying a constraint. And I, of course, provide the body of the constraint. And we can do so here. And we can retrieve the constraint list that is currently applying to the battery. We initially had 2 constraints, the max energy and the min max power. We now have 2 additional ones, a power of 258 watts and a power of 0 as backup. Of course, now the battery is charging with 258 watts. Okay, now we continue, and let's say we may want to actually delete the constraint we just set. And so for that, we just pose a delete request to our API. And this is where it's important to have retained the battery constraint ID, because you want to only delete this specific constraint. We're going to do so. And if we check our constraint list again, we now see that we only have 3 constraint left, and that the power applying is now 0. And we have removed our constraint of 258, and our battery has now stopped charging. So you may wonder why there's like a little bit of delay between the time when I set the constraint and between the time it's visible on the battery. This delay is actually due to the minimum control interval of the battery, so it has nothing to do with the API. The battery can be controlled at a certain time interval. I believe for this one, it's maybe 10 seconds. And so this is another advantage of our API. You don't have to worry about this. We take care of when this should be applied. All right, then the last, our battery is charging the surface again, I guess. Now, the last thing I would like to show you is the use of the prioritization, which we discussed with the EV. Okay, currently my EV is actually not charging because, well, my battery is already charging, and there is not much I'm feeding into the grid, so I'm not going to be able to start my EV with 78 watts. But maybe that means that currently I'm setting a default value to charge my EV to a power level of 0. But maybe a user wants to leave in a couple minutes, and he thinks that 40% state of charge for the EV is not sufficient. So he would like to have a fast charge of his EV. In this case, he would just request a larger power. For example, we could say 7,000 watts, and just put a higher priority level to this constraint. So let's do this. And so we would post a constraint just like we did it previously. So a post request to our base, a URL with this time the EV identification number, and say we would like to post a constraint with the default, which is the lower priority constraint, and the main constraint. Let's apply this. So initially, we should see the EV that will start with to charge with 7,000 watts. And here, of course, because we don't want to wait for the full charge of the EV, I've only left the constraint to be applicable for 20 seconds, and then it will go back to 0. You can now see the EV charging. It will charge for 20 seconds, and then will go back to 0, which it just did. There's one more question that may have arisen in your mind by observing this. The EV is not charging exactly with 7,000 watts. It was charging with 6.9 kilowatt. Well, the reason for that is that the EV charging station only accepts round amperes on each phase. And so you don't need to know this. The API and the control gateway takes care of this for you. So we make sure that we actually can apply the closest set point you required based on let's say the restrictions or what is accepted by the EV charging station. So I believe we are done with the live demo. And I would be happy to now go to the questions. You mentioned that the battery set a constraint earlier. How does it do that? Oh, it's actually, so we retrieve information from the driver. So we develop driver that can communicate directly with the communication via the communication protocol of the battery and retrieve information from the battery. And typically, the maximum, the minimum and maximum power are returned by the battery or by the battery inverter, as well as the capacity. So this is handled let's say on the control gateway side, and it's provided as an information to the API, so you can retrieve it to build your energy application. It's a very important information. How is the API encrypted? That's an excellent question. I'm actually more focused on the application part of the API, but I believe my colleague Philip would happily respond to this question. Philip, if you...
Yeah, sure. Yeah, the API is encrypted via TLS. So first from the Gridbox side, so the gateway side, we are talking to our cloud, which is encrypted in TLS. And from the other side, so the caller of the API also uses TLS in the end. And all of the users are able to retrieve like tokens to have like a certain permission to, for example, set constraints, read out flexibilities, etc.
All right. So with regard to the plan B, in case the internet connection fails, so we definitely that's one of the reasons why we have a grid box to which our devices are connected. So if the internet connection fails, the grid box can continue applying the last set point that was sent, and also the grid box we can define like a fallback mode or a fail-safe mode to continue operating the system in a safe manner up until the internet connection is back. For that specific question with regards to the cost of the grid box and also like the payback for a household, I would rather ask you to contact our sales team to discuss this in more detail with them. Yeah, so definitely we can integrate new devices and manufacturers. We continuously actually update the number of devices, manufacturers, and models that we can handle. But also in the future, we might actually open our solution to a third-party APIs to even offer a broader set of options. Currently, the constraints are set at the appliance level, but the cluster level is the next step for our API. It depends. Actually, there could be different EKT configuration to actually connect a neighborhood or like several houses in a neighborhood and control them. We could have, what matters is that all the appliances we control are accessible in the same local network. So either we have 10 separate grid boxes so like one per household, or we have one central grid box. And for example, all the devices are connected to that central grid box via, I don't know, optic fiber, so that all the DRs we would like to control are accessible. But in some cases, the house owner may like to have his own grid box to also do his data visualization and so on. And so, like I said, we are currently onboarding our first beta users, and if you sign up, we will contact you as soon as it is your turn. I see more questions coming. I see, are you planning to allow energy suppliers to control certain devices to manage the load on the grid? For example, a user could set a constraint that allows the supplier to switch off the heat pump for 20 minutes if necessary. Indeed, so we do have a smart grid ready interface, right, that allows to switch the mode of the heat pump operation from, let's say, a normal operation to a reduced operation or an increased operation, depending on the status on the grid. Of course, it depends on on the legal framework and how all this evolves also in the future. But yes, definitely the API can be used for that purpose as well. So I said there is a 10-second delay for the controlling. What if we need to act fast, for example, for peak shaving? So like I mentioned, there is actually no, let's say, time constraint that is really introduced by the API. The most, let's say, restrictive or constraining items are the communication speed, so like the internet connection, but also like how we do the computation of our constraints and also how we access the database. So we can basically tune the system so that it fits the requirements of your application, for example, by using different data centers, by entering some kind of, like we mentioned, backup with our local control gateway. And of course, we can increase the speed at which we send the set point to the battery so that it fits your application, provided, of course, that the battery can react this fast. But typically, you could send set points to some batteries every second or 2 seconds, and that would be no issue. Does the API allow to sell flexibility to the market? So the API itself would provide you all the information you would need to be able to sell this flexibility, but the API itself does not build the energy application to sell the flexibility. So you could use the API to know at any point in time what is the status of your DERs, how much flexibility they have, so like how much extra capacity you have, how much power modulation you can do upwards or downwards. All this will be made available by the API. And then, of course, you could sell it to the market. Are the constraints shown in your user interface? That's a good point. Not so far. Because, I mean, what is shown in our interface is the result of all the constraints. However, I'm taking notes of this as a suggestion. Of course, you could also integrate your house automation with the API. So you could use the API to connect to different devices that you can communicate with in your house. Okay, so I believe we have reached the end of our presentation and our webinar. Sorry again for the interruption due to the internet connection. We will provide you with the recordings, and of course, feel free to contact us and reach out to us if you have any further questions. Thank you very much for your attention, and we will then close the webinar. Thank you. Bye.